so we're back in chapter 10. We've been talking about the business math or consumer math portion of our course. And so we're up to section 10.3 now. Section 10.3, we're going to talk about compound interest. So if you've got your note packets, hope you're following along. I want to read with you what the first part of the paper says before we get into actually using the formula. And know that you can always go to your book and find better graphs and applications and nice little write-ups about whatever we're talking about. Your book actually reads pretty well. I always say this about this math book that we're using. It's a pretty good read as far as math books goes. If you look at the just dry algebra books, they just have example, and concept, and not much application to the real world and graphs and charts and things that we would recognize. Lots of pictures in this book and real life applications. So I encourage you to look at that as well as watch the videos. So anyway, there's this one quote in your book, I took this from your book, from Albert Einstein, who said of compound interest that it was the most powerful force in the universe, which is an amazing, profound statement for him to make. You know, we really think a lot of Albert Einstein, so for him to say it's the most powerful force in the universe, that's a pretty big statement from him. So you can kind of look at that a little bit more, maybe study why he said that. But if you have lots of time to invest money, the more the time, and we are going to get to this formula we're going to use, so time, the bigger the time, the better your outcome is going to be. Compound interest really makes the difference over simple interest, which we studied in 10.2, the longer the time goes. In the short term, you won't see a big difference between just doing a simple interest problem compared to this compound interest formula we're going to use, but time is what makes the difference. So if there's a lot of time involved, compound interest has repeated calculations on the principal to where the longer the time, the bigger the impact. So I think that's what you'll find, kind of look into it a little bit more, but that's the big difference is time. And the next paragraph says, an investment is the use of money or capital for an income or profit. We can divide investments into two classes, fixed investments and variable investments. In a fixed investment, the amount invested as principal is guaranteed, and the interest is computed at a fixed rate. For example, money market accounts, savings accounts, and certificates of deposits. Back not that long ago, maybe my parents, my grandparents definitely, if they could put a little money in a CD at the bank, they could actually get some decent money off of that account, maybe a 10%, 12% return on their money. So it was worthwhile, but now the interest rates for savings, CDs, savings accounts, you might know, is very low. But it's still something. It's still positive money that you get instead of owing money, so it's still good, but it's just not like it used to be. Those types of fixed investments aren't as common, I would say, now. People have moved to the mutual funds and stocks and the stock market, and that's variable. So in that kind of thing, you don't know the interest you're going to get from day to day, and so that goes up and down, and it's a little more risky. Okay, so next paragraph. In compound interest, simple interest is earned for a period of time and then added onto the principal. Now this happens whether it's a fixed rate or a variable rate, we still have the concept of compound interest on our side. If we put money in, and most things are computed with compound interest, where they take your principal and every month or every quarter or maybe just once a year or maybe it's a daily thing, but they add on your interest incrementally. So they add the interest onto your principal instead of waiting till the end of the whole loan like we did on the interest, on the simple interest. They just waited till the end and calculated the total interest owed at once. But this, we do it incrementally, like maybe every month, like I said, or every 6 months, they add on your interest, and then you have a bigger principal amount, maybe just a little bigger, but it's still bigger. So when we do the next calculation, it has an impact on that. So it rolls into bigger money the longer that it goes. But it also works against us if it's a loan we're taking. It's going to also work the other way too. So as we talk about money, you know, we talk about taking out loans when you borrow money, but then there's also the side where maybe you're saving money. So it's on your side if you're saving money, but it's kind of working against you if you're taking out a loan. All right, so in this one, this last paragraph, it says, in compound interest, simple interest is earned for a period of time and then added onto the principal. A new or higher principal is now used to recalculate. Each time the interest will increase. Imagine doing this calculation over 50 years monthly. Okay, if you had to recalculate your interest, in the last video we kind of talked about number crunching. This would definitely be a big number crunching thing. If you recalculated every month your interest and then added it on and did that for 50 years, that's a big number crunch. This would be outrageously time consuming though, but luckily we have a formula that will do that for us, and that's what I'm leading into. So that's what compound interest formula does, is it rolls the interest earned onto the principal repeatedly. It does that calculation repeated into one formula. All right, so let me introduce to you the compound interest formula. This is the formula, and to read it, I would say A, or the accumulated value, what it rolls into with interest and everything. A means accumulated, or the future value of the principal with the interest rolled onto it. So the total accumulated value, it's done the adding into it already. So A is considered future value or accumulated value, and it will equal the principal, just like our old formula, the principal, the amount invested, or the amount that you owe on a loan, the principal amount, and then parentheses, so the quantity in here we do first. The parenthesis has the number 1, which actually serves to add in the principal each time. So it actually works so that it adds the principal stated amount each time for you, and that's how the adding's happening. But 1 plus the rate of interest, just like the other formula, we'll change it to a decimal and divide it by n. N is a new player in this. I'm going to talk to you about what n is. Whatever n represents, though, is used again in the exponent. So this number will be the same number in your calculation. So the n times time just like before. So this new thing, let me talk to you about that, is n. N represents, and I've written it down here and also in your notes, is the compoundings per year. So how many times do they add in your interest each year? If it says, and I have a list also on your notes for you, if it says annually, that means once a year. It's just going to add your interest once a year. And so we'd put 1 for n, 1 for n, if it says annually or yearly. If it uses the word semi-annually means twice a year. So compounds per year would be 2 if it's semi-annually. So we'd put a 2 here as well as there. And then quarterly, that means 4 times a year, so we'd put a 4 for each of those. And then monthly would be 12 months in a year, so 12. If it was daily, we might say 360 or 365, depending on the directions, and so on. So N is how many times your money is calculated on per year. If it's a monthly, that's 12 times a year, and so on. That's what goes here. And then T is how many years it is. If it's compounded in months, you'll put 12 here, and then if it's for 3 years, you'll put a 3 for T. So T is the amount of time in years unless otherwise stated. All right, so those are the players. Now we'll get to working some problems. So as always, once we start working problems, I like for you to give it a shot yourself before you access the final answer. So if you read the first problem, number 1, it says we've got $3,000 principal at 5%, so we make that 0.05. It says the word semi-annually, so that's 2 for n there as well as 2 in the exponent. And then it tells us to do that for 2 years. Now, from there, it's just a matter of getting friendly with your calculator, making your calculator do this calculation for you. The number one probably question that I've got over the years from teaching this class online would be from students who ask me about getting this out of their calculator. So I do want to talk to you about that a bit, because otherwise it's just a matter of typing this in. We're done otherwise. So our calculators know order of operation, right? We've talked about that before, how that they know they're programmed with order of operation. So if I type in 3,000 times, and it's questionable whether you have to put a time sign there or not. Some calculators, yes, some not. So that you'll have to play with your calculator and see. But your calculator definitely knows that a parenthesis means do this first. So if we type it in, and some of you all have a fraction button, you type that in as a fraction. Some of you type that in as a divide. Either way is fine there. That won't give you any trouble. Where you might have trouble is if you type in up arrow or your X to the Y button that you use to make an exponent, If you just type in 2 times 2, your calculator, which don't do this, your calculator will think, do this first, then what else comes after order of operation? After parenthesis, you do to the second power only, then you would times that answer by 3,000 and then times it by 2. That would be order of operation. So your calculator has no way of knowing this is supposed to be a set up in the exponent. So you need to tell it, and some of your calculators let you kind of already have that hovering as a superscript, as an exponent, so that you don't have those problems. But general calculators would need a parenthesis around that 2 times 2 to tell your calculator this is a set that belongs as an exponent. So we need to either, in our head, just call that 4. That's probably what I would do. You can say 2 times 2 is 4, and then you have less things to type in anyway. Just say up arrow to the 4th. You need to kind of do that separately. That's in the exponent, and that's the number 4. That would solve that. But just know, if you just type plain old 2 times 2, that will get you a wrong answer. So you do need to either go ahead and call it 4 or put a parenthesis around this to tell your calculator that calculates first. This parenthesis is raised to that parenthesis and then times 3,000. Or you kind of just do it, order of operation. Sometimes I'll do that because it's easier for me than trying to make everything perfect in my calculator. We all know order of operation from our studies, so we could just kind of type it in the way we want to do it. I might start with saying 0.05 divided by 2 equal, then plus 1 equals on my calculator. Kind of control the calculations myself that way. Get that answer, then raise it to the 4th, and then equal that out, and then times it by 3,000. That also works. So different ways to handle it, but like I said, this is mainly making peace with your calculator, so do practice that along in your calculator. For those of you that's been using your phone calculator, which I know that's great, but sometimes it gives us more trouble with things like this unless you've kind of turned it sideways and got the better calculations going there. But just whatever you're going to do for your final exam, practice it that way. And you can't have your phones at your final exam, so do practice this on a calculator that you plan to use when you take your final exam, so you'll be comfortable with that. So I see that happen sometimes. Students will have only use their phone calculator, the one on their computer screen, and then whenever you have to use, like a friend hands you a calculator or one they give you at the testing center, you're just not as comfortable with it where you haven't practiced. So that would be one recommendation I would make for you. Practice on just simple calculators, all you need, but practice it on your own so you feel comfortable with how it works for you. All right, so go ahead now and try the next couple. I'll tell you what the final answer should be here, but hopefully you're pausing and practicing that. Number 2 is, 2 and 3 are very similar, just more practice. We have $5,000, 7%. This one is quarterly, so notice how I used a 4 and then times 3. That answer should give you 6, 1, 5, 7, and 20 cents. To the nearest penny, when we're doing money, we round to hundredths place, or the nearest penny. Okay, and then number 3, we have $5,600, 7.5%, which I need to change to a decimal. This one is a monthly compounding, so it should be a 12 for monthly, here and here. And then we do that for 10 years, so times 10. Again, type that in your calculator. Just go ahead and call that 120 or use a parenthesis, the main thing there. The final answer should be, this one's a nice number. Notice though, we left $5,600 in a bank account, and it had a pretty good interest rate, 7.5 interest rate. I say it's pretty good. And it was compounded every month, and then 10 years passed. So that's a good amount of time. But notice your $5,600 that you invested turned into more than double. Did it double? Yeah. Yes, it more than doubled to $11,827 there. Oh, it almost doubled. I was having to think about that. But anyway, it grew a lot. So that's what we want to see happen with this compound interest, is seeing that this money turns into this money, and it adds in the principal you started with plus all this compounding interest. So we didn't add any principal, and it grew to that much. So that's a pretty cool formula to help you see that. Again, on number 2, your $5,000 turned into almost $6,200. So you gained some interest. If you have a question on your homework that says how much interest did you gain, you simply subtract those two to see the difference, and it's all interest that you're gaining on those.